So good afternoon. Welcome to this next LSEC Cybersecurity Experts from Home webinar, directly from Belgium, Leuven in this case. We're happy that you've made it to join us today to our next network and information security, but also industrial automation security activity. This is the third one in the series. Last 2 weeks, we had actually quite some interesting perspectives on industrial cybersecurity from both the worlds of investigations, namely from Mandiant in terms of solutions coming from Trend Micro, and ideas on network and information security directives from Phoenix Contact. So last week we had a bit more in terms of further developments on potential challenges and activities. This week we'll be focusing a bit more about additional ideas that could lead to first steps in some cases towards industrial cybersecurity, how to tackle it, how to get to a risk-based approach on cyber security, but also on how, in this case, larger organizations are applying cybersecurity for their industrial automation activities. And not the least from a company that has been in industrial automation for quite a number of years, namely ABB. To kick this off, I'll, as usually, do a bit of an introduction on our part. So LSEC is an association of IT security companies. We've been around for 2 decades as a spin-off of the University of Leuven, where amongst others, the AES algorithm was developed. Today, we work with about 500 cybersecurity companies, both solution providers, technology providers, and system integrators and advisory, on thinking what the new cybersecurity will look like. So we call this digital security, and we call ourselves Digital Security Catalyst because we work with about 15,000 end-user companies, which are looking to do their digital transformation to some extent, or staying within the remit of their existing manufacturing domain, but still looking to apply better ways of cybersecurity. So we have different vertical sectors that we focus into, both financial sector, media, and telecom. This morning we had a specific webinar on 5G and 5G security with operators going from Indonesia to Norway to South Africa. Today we'll be focusing more on the domain of industrial cybersecurity. As you can see, we organize trainings, we organize market assessments, and then specifically innovative projects all along. One of the important projects that we are currently running is a project called Trinity, where the cybersecurity for robotics activity is part of as well, and which in this case is a community of experts in robotics and in cybersecurity. And by bringing those together, we hope to be able to also influence that domain. So another potential aspect to talk about a little bit later on. New to these types of introductions is the fact that we are also active in other domains in industrial automation, and then specifically in the first place here within the project called Connected Factories 2, to provide ideas on how cybersecurity is actually influencing the way that connected factories are evolving as well. What you can see here is a slide which we have been developing, and a concept and a framework which we have been developing, whereby we see how the world is evolving for manufacturing companies and companies in the domain of producing goods and services. So both from process as well as discrete manufacturing, it's a collaboration between different research institutes and also industry, whereby we're looking for, okay, what is the current status of a company? What is its current status in terms of digital activities? And from this, we developed different pathways to help them getting across in those different schemes in taking the next steps towards a digital platform. So do they have to go from, for instance, in this case, Excel, Word, directly to an online digital platform, or are there some intermediate steps to consider? In that respect, we consider definitely also cross-cutting factors, which are, for instance, things like business cases, or for instance, also cybersecurity. So in a similar type of context, we look into those manufacturing environments, if you like, factories that have maybe experiences with how they need to run a factory, but not always how they should best apply cybersecurity for that matter. And so in the world of digital transformation, we help them identifying ways to do that by providing them with insights into technologies, into methods, and different policies on how to get there. So the different levels apply equally here. Also in Flanders, we have a couple of activities on supporting industry. One was an activity which was called 3if.be. It's a European platform actually where we use different existing activities, business models, and concepts to help companies doing their digital transformation, and mainly from the manufacturing, by providing advisory, by providing business models and existing capabilities like technologies in order to get there. As a result of this, we've developed a platform together with some partners, which is called Factory Sense. With Factory Sense, we actually go into factories deploying a series of industrial IoT sensors and a digital platform, collecting data and doing analytics in order to help companies in taking those first steps. It's a platform that was derived out of the LSEC and TRIF activities as a spin-off activity. Taking it back into the world of 5G, we see definitely introductions into new types of environments where a lot of 5G components could be placed, and where we see that there's a potential new ways of industrial automation using technologies such as IoT to enable new facilities and enable new business opportunities. Today, two topics that we would like to address. First, I'll hand over the word to Ragnar, who's dialing in from somewhere at the north of Germany, talking a bit about an industrial cybersecurity perspective from ABB as a vendor, but also, of course, from the way that they have been approaching cybersecurity towards their own customers. And then Vincent from Torion on more the cybersecurity risk management perspective from an industrial context, and the ways that they have been having experiences on the best to approach this into an industrial context, going towards an ISO certification, and maybe also in this case preparing for NIS compliance. So with these introductory words, I'll hand it over to you, Ragnar. So thanks in any case for joining. I see that you are ready to go on a ship. Go ahead, and the floor is yours, Ragnar.
Okay, thank you. You can see my screen?
Yes, I can.
Okay, very good. So just allow me for a brief introduction. My name is Ragnar Schierholz. As Ulrich already mentioned, I've worked for ABB for about 13 years now. I'm responsible for ABB's industrial automation business, cybersecurity. So I'm looking after the technology portfolio and specifically the security of the technology portfolio in our industrial automation offering. And I'm also looking at security technology to support our cybersecurity portfolio. So I like to phrase it as I'm looking after security as a property of our market offering. So security as a property of a DCS, for example, as well as security as an objective of our market offering, where we, for example, provide cybersecurity services. And specifically, I focus on the technology part of that to make sure that we have the necessary technology foundation for all of this. Today, I'm not going to talk very much about deep technology topics, but I will start with a mechanism or an approach how to introduce a cybersecurity management for OT. Because what we see very often in our customer base is that there's a little bit of a chicken and egg problem, or the deer in headlights problem. People understand that, yes, probably security is something that they should devote some attention to, but there's in often cases not the very detailed know-how about cybersecurity in OT, or in the organization there are cybersecurity experts on the enterprise side, but they have no or limited information or insight and experience in the OT world. So there's this deer in headlights situation. You know there's something you should be doing, but you don't know where to start, how to get out of the headlights. And we have looked at a couple of references, and we provide guidance to our customers how to get started and to take them from essentially zero or wherever they may be to a relatively mature, resilient OT operations. So just given in the times and situation that we are, I think it's probably also helpful to understand with the current constraints that we live in under the COVID-19 situation, what can we as a cybersecurity community do in order to help our respective employers to survive the crisis. And for me, this is very much in line with the message that we're giving in and from ABB for a while already. Cybersecurity is an enabler of modern operational principles. If you look at digital transformation projects and digital operations of OT systems, there's higher connectivity, there's more exposure of data, so the exposure to cyber risks and cyber threats is higher. And in order to do these digital transformation projects, and in order to do them in a responsible manner, controlling the risk, you have to have cybersecurity. And today, many people are constrained to work from home, like probably most of us today. And that means in OT environments where facilities are oftentimes difficult to access, remote work has already been a common practice in years. So what we have as experience from there, we can take to other OT environments as well. Offshore and oil and gas, for example. It's difficult to get there. You need safety training, you need helicopter rides, so it's expensive. And there's a clear business case for doing as much as possible from remote. Mining, where you have remote areas in the middle of nowhere, in the outbacks in Australia or in the Andes Mountains in Peru, where there's limited interest in living there, but you actually go there only for work. So as little as you can, you want to go there. So we have security controls in place for those industries, for those scenarios, tune parameter protections, authentication, authorization, monitoring. So that kind of remote work concepts, that can easily be applied also to facilities where in normal times it is easy to commute to, like a chemical facility in Ludwigshafen, for example, in Germany, or in other kinds of places like that. But in these current constraints, it's not allowed, or it's not in our interest to go there. So this modern remote operations, distributed flexible operations under controlled risk, that is, I think, where we as a cybersecurity community can also help to solve and to address the COVID-19 constraints. That said, though, how do you get started in order to introduce a management system for cybersecurity? Everybody is touting that cybersecurity is a process, not a project. It's about people, processes, and technology. It's not just a technology that you deploy. So essentially, it comes down to you need a management system to drive all of this and to keep control. How do you introduce such a management system? That's not always easy. And I want to explain to you what we typically recommend from ABB's perspective and how to do so. I have a couple of slides also on the motivation of why cybersecurity is specifically relevant in industrial control systems. I'm assuming that since most of you are here today, you probably have enough motivation, but nonetheless, I would like to keep the slides in the slide deck. I will not spend too much time on them today, but if you want to use them, for example, to motivate why you in your OT operations need to do a cybersecurity program towards your own management, please feel free to reuse those arguments and those slides, those messages. And if you have questions, please feel free to reach out to me. Information about how to contact me is widely available on the web, and I'm sure Ulrich will be happy to forward that as well.
That is correct.
So as I said, I'm not going to spend too much time on these slides. Essentially, we talk about 4 different myths that are misconceptions that we encounter. I'm not relevant. Why would anybody go after me? Security doesn't pay off. I have an air gap. I'm protected. I have no connectivity to the internet, so I'm protected. All those things are common misperceptions, and they have proven false. And so this is how we typically try to address reservations of management in OT, why security is really not relevant for themselves. But core of today, I really want to focus on an approach and how to introduce a cybersecurity management system. In ABB, we've come to the conclusion that cybersecurity is essentially a risk management practice. It's not much different than other risk management topics as well. The reality is there is no such thing as 100% or absolute security. There will always be a residual risk. It's not technically possible in most cases, or where it may be, it's economically not reasonable to reduce the risk to zero. And then based on that, we know that while there is an accepted residual risk, we have to continuously monitor it, especially in cybersecurity, where the threat landscape is an evolving target. So we have to have a continuous process. And ultimately, the objective of that process is to keep a balance between the impact that usability and cost have when we introduce cybersecurity controls, and the risk reduction that we get from those cybersecurity controls, so that we have a risk at an acceptable cost and at an acceptable residual risk level. In ABB, we look at cybersecurity holistically. We have to cover both our product as well as our project activities, where we develop industrial control system products and where we commission those products in commissioning projects, engineering projects with our customers. And thirdly, we also want to support our customers throughout the life cycle of the plant, of the industrial operation, while general day-to-day operational practices and maintenance practices and potential reviews, periodic reviews and upgrades are relevant also from a security perspective. So we see currently a lot of convergence between IT and OT, so the digital transformation. We see a mix of skills that are relevant there, and that is essential also for cybersecurity. You will not gain the operational people's trust if you cannot talk their language, if you don't understand how engineering works, if you don't understand what a safety system is. On the other end, you also need the IT background in order to understand how those kind of systems actually nowadays rely on IT technology and what the risk is that comes from cyber manipulations. Introducing a cybersecurity management system, the good thing is there are standards out there and other guidance documents that you can turn to. The challenge is there are so many of them, so you have to make a pick, you have to make a choice. We've looked at the cybersecurity framework from NIST, the US National Institute of Standards and Technology, that had introduced such a framework. We looked at the DHS, the Department of Homeland Security, Cybersecurity Capability Maturity Model, and at the IEC standard 62443, specifically the security management system part. And there are actually quite a number of similarities. They slice the elephant slightly differently, but they all talk about different cybersecurity domains, capability domains. And if you compare the list in the ISO IEC standards, it's 15. In the DHS document, it's 10. But there's large overlap. Nobody invented the wheel anew. On the maturity side, there are different maturity levels ranging from essentially 0, nothing is practiced or performed systematically, all the way to a continuous management. And there's an approach progression and an institutionalization progression. So the approach progression means you become more comprehensive in the things that you do. And institutionalization progression means you become more rigorous in how you institutionalize the practices. However, if we look at the first step from level 0 to level 1, that comes with the introduction of something around 50 to 60 practices. And in all practicality, introducing all these practices like threat and vulnerability management and identity and access management, situational awareness, workforce management, all those things are quite complicated to introduce. They are a change in operations, and introducing 50 practices at a time typically kills the availability of an organization to digest change. So we've come to the conclusion that going from mil 0 to mil 1 is not possible in one step. But typically, if you run such a program, you need evidence that you've actually achieved something relatively quickly. So you need to tell your management, look, this is what we have achieved. And if you need multiple iterations to go from 0 level to level 1, you will not be able to produce such evidence in time. So we actually designed a little more lean approach where we start with stage 0, how to get started. Very fundamental, getting started, raise awareness and management, talk to the people, identify the risks in the respective language that they understand. So if you talk to an enterprise risk management function, tell them where the organization creates value. If you are in a chemical facility or if you are in a refinery for an oil and gas producer, you're probably relatively close with the OT operations to the value add of the corporation. And then you can outline how the balance between risk management for cybersecurity is between the enterprise system, where you have a typical CISO office, and the OT system, where you may have nothing. And balancing the risk of what is at stake in terms of added value versus the controls that you have in place, that typically helps to get an enterprise risk management's attention. On the other side, if you talk to OT people, you have to understand what their priorities are: safety, reliability, deterministic nature. And if there's an intruder that nobody is aware of, those are all at stake. And that's how you can identify the biggest areas of risk, just by talking to people and understanding where the organization is. You don't need a sophisticated risk assessment for that yet. Actually, when we then start with the next stage, introducing basic protection, essentially cybersecurity hygiene, we still do not recommend to do a sophisticated risk assessment at this stage yet, because that takes quite a bit of effort and is at a first stage a planning exercise. It doesn't give you a risk reduction. On the other hand, we have not yet come out of such a risk assessment where these basic hygiene protections are not part of the recommendation. Basic hygiene being patch management, keep your software up to date, have endpoint protections in place, harden the endpoints to the extent possible, know how to back up and how to recover from your backup, such in the case of an emergency or of need, you are able to restore operations. If you have a ransomware that couldn't be prevented, at least you know how to get back up to normal operations. Have network management, at least at the parameter of your OT system. Do the very basic monitoring, at least of those practices above. You don't necessarily have to full-blown SIEM for this, but understand, are you actually doing the patching that you've set yourself as a target? Are you actually having up-to-date endpoint protections in place? Those kind of things you can monitor with relatively simple and unintrusive tools. And unintrusive is a very important element of this stage. At this stage, we're not changing the day-to-day operations. Most of these things can be introduced if you have a sufficiently redundant system without shutdown. You can introduce a patch management. If you have redundancy, you can actually deploy patches without shutting down your operations. You can run malware protection without shutting down. You can apply hardening. Again, with enough redundancy in your system, you can do that slice by slice, and you don't have to take down your entire operation. And also with the day-to-day practices. The people that come into the shift and they'd run the operations room, that run the control room, they can still work as if they did before. But you can already show risk reduction by select examples. And that gives you then the argument towards management. We should continue this. We need to drive this further. And the next step then really is the comprehensive security assessment, where you have a detailed understanding of your specific organization's risks. I'm relatively certain, without having done these basic practices, those will be a part of your risk assessment anyway, so you can start with them right away. Now, once you have a more detailed understanding of your specific organization's risk approach, then you can establish a security management based on those results, based on those particular risks. And then you can focus, and then you can establish the security practices more systematically across the board. You can develop security policies and procedures that are specifically tuned to your environment, that actually take into account the specific risks that you have and the risk appetite that you have identified in your risk assessment. What kind of risks are you comfortable with, and which ones are you not comfortable with, you as an organization? Then you can do more security network management. Then you can actually segment your network even down into the OT system, into the control system. You can have access control on an individual level. No more operator password as operator accounts, but tuned individual user accounts where you have traceability. Of course, that then will have an implication on the operational practices. Now your staff in the control room needs to change their practices, because now the shift handover is not just telling the others what have happened in your shift, documenting it maybe on a piece of paper, but now you actually have a managed log over of the users that are using the system. And you will want to maintain visibility of the process. You will want to maintain the control of the process. You cannot risk loss of view or loss of control just because you have a shift over. So there you have to have a change in daily practices. And then you can also tune your monitoring, that you are indeed situationally aware of what happens in your system. And you can start planning incident response beyond just a backup procedure in place. Then you can actually become more resilient, and you can take a first stab at being compliant to regulatory standards like NERC-CIP or the IEC 62443 series, or other standards like in Europe, the NIST directive, where your respective government may have the authority over the critical infrastructures. Or even if you're not critical infrastructure, you have relevant OT operations, so the standards may become become helpful for you to justify towards your insurance that you're doing the right things. And lastly, then, once you have continuous monitoring and management practices in place, then you can do continuous improvement. Then you can do, for example, things like threat intelligence, be able to foresee, to predict what kind of things are ongoing out there and how could they affect us. So that you're not caught by surprise by the next wave of attacks or by the next principles, techniques of attackers, but you have seen that coming and you have prepared your organization. That really then is the highest level of maturity that we typically also see not practiced everywhere, even on the enterprise side. There will be different levels of organizations that will set themselves a different level of maturity as a target, and not everybody needs to reach the last step. So with that, I want to briefly highlight also a little bit of a notion of what do you need to face in order to tune your maturity level. I typically talk about a dichotomy of attacks, of incident types. There's the generic attacks, the white noise. As soon as you have somewhat of a network connected system, you will see these kind of events happening. Just generic, not tuned to an industrial control system, leveraging generic malware from the IT world or from the internet based on known vulnerabilities and exploits, spear phishing, those kind of things. Typically, any particular case of this has limited to moderate damage in an industrial control system, but it can quickly aggregate. Take WannaCry as an example. That is a very, very generic attack. It was not focused on white noise. It was not focused on industrial control systems. It was generic vulnerabilities. Because they were previously unknown and it was only relatively recently fixed in the Windows operating system, the scale was relatively large for such a white noise, but it was not addressing control systems very specifically. So if you look at where in the control system it has affected, typically it was the HMI layer, where you have Windows operating systems and Windows servers and Windows clients. It did not go into the control level. On the other end, you see targeted attacks, the advanced persistent threat type. There you typically have a highly motivated attacker with significant resources, custom malware based on often zero-day vulnerabilities, specifically tuned to a particular target environment. There's typically large damage or moderate to large damage, only concentrated on very few victims where this was really tuned to. And potentially there's a large attention in the public. So the Stuxnet kind of attention where everybody screams, and how could that happen to such a critical infrastructure or to such a critical operation? If you have a power outage, that's the kind of reaction that you would get. If you think about where on the technology that maps, first, this is what I'm using here now it's the analogy of the ICS kill chain that was contextualized and conceptualized by the Lockheed Martin organization. So they essentially design or define the different stages of a control system specific attack. And first you have a generic planning, and then you have the ICS specific planning. And both stages essentially go through very similar stages of reconnaissance, weaponizing, delivery, and exploitation. Just the one is to get a foothold in the organization, and the other is to really go after the ICS. Now, if you think about these APTs, those are really the ones that get to the second stage. And if you look at your ICS architecture, this is where the difference is between the white noise and the APT scope. The white noise typically ends at your client server network because it's not tuned to use these industrial specific protocols that would go down to your process control or safety control networks or even your field networks. And if you have proper segregation, if you have proper network perimeter protection, you can defend against those things with a relatively simple set of mechanisms. Security updates, endpoint protection, secure remote access, hardening, firewalls on the hosts, firewalls towards the IT side. With that, you can probably keep away 90% of the white noise already. But when it comes down to the next stage, then you actually have to go one level further. Then you do DOS protection, security event monitoring, Windows authentication on individual user account basis, secure file exchange, proper zoning all the way down into your network, into the control system, securing that layer with, for example, IPsec and things like that. Even if your control system doesn't use protocols like OPC UA, where security is built in or can be used built in, even if it uses legacy control system protocols, you can still do something on the lower levels. And lastly, then you actually get to your client network to your control network, where you can do anomaly detection, multi-factor authentication, all the way into the embedded devices. And for that, however, you do have to face the fact that potentially your field instrumentation is outdated, is 10, 15, 20 years old, and not all of these things will be possible on that equipment. So then you get into an expensive exercise where you will have to shut down your plant for remodeling for a while. But if you've done the first stages, you probably have reduced the risk to a level where many organizations are already accepting the risk, where the risk is at an acceptable level. And for others, then you have enough justification why you need to take that stage. That said, that's essentially in a nutshell how we typically recommend to organizations running OT systems to go through various stages of cybersecurity management maturity. And so, Ulrich, how do you want to run this? Do we open up for a couple of questions now already, or do we wait for later and allow Vincent to take a deep dive on the security risk management and assessment?
Yeah, I would say we can do a bit of both, in the sense that putting out a couple of questions and then giving the floor to Vincent in any case to take it forward. So thanks for that approach, Ragnar. That makes a lot of sense. I think it's a good introduction in any case also to what Vincent will be bringing later on, because you bring it also from a bit wider perspective, but at the same time also a bit pointing to some of the things that Vincent might be referring to later on. Now, my biggest question is, of course, in your case as well. How do you within ABB apply these mechanisms, both from you as a company as well as also an industrial manufacturer to some extent, because you do produce also like the nice equipment that you're showing us here now, and then obviously also from a wider range, because many of those let's say mechanisms, methods, procedures are obviously and typically good for very large enterprises where you have teams and cybersecurity managers and CISOs that they can start handling these things, that can start building it from, let's say, the ground level up, and then working their way towards a scheme of activities to be done over the course of probably months and sometimes even years. However, in many cases, there is not that much time, so we need to take it a little bit more practical. I think that's also something that Vincent will be tackling. But in any case, in the view of within ABB, how do you see that?
So yes, first of all, we do see ourselves both an OT operator as well as an OT supplier. So we do have factories ourselves. We have some 400 plus factories in warehouses in ABB that are to a varying degree, but in general, highly automated. So we eat our own dog food. We do these security assessments. We do, for example, perimeter protection. We maintain contracts with our suppliers that we have an up-to-date and evergreen systems where we can. Of course, retrofitting that to 10, 15-year-old production facilities is challenging. We understand that. And again, that's where we then get to the next stage of maturity, where we then, in such cases, do a detailed analysis of our risk, mitigate the residual risks, and get management buy-in in those risks that, yes, this is how we can operate, and this is part of the motivation for a upgrade of the facility when it really comes around. And then typically nobody does an upgrade just for security, but security is a building block in the use case, in the business case for an upgrade. And with regards to the small and large organizations, from my perspective, there's not such strong of a correlation between the size of the organization and the approach to cybersecurity. While admittedly on the small size, we typically find less self-maintainers. Typically, the smaller organizations don't have the luxury of having the subject matter experts on all of these various topics. So they typically are more on the side of the service consumer, where the maintenance and the security protections are outsourced to a managed security service provider, which, for example, could be ABB. On the large organization, I do still see the variation, though. There are large organizations that still say, it's not my core expertise. Shell, for example, the Dutch oil and gas organization, they have repeatedly stated publicly that securing their OT operations and the OT control systems to them is a commodity that they buy from suppliers. It's not their core competence. Shell considers it not to be their core competence to operate a DCS. That's a means to an end for them, and they buy this as a service as their strategy. While other large oil and gas manufacturers, for example, consider the OT technology a core element in their value chain, and they feel that indeed they have to have the in-house competence to manage this, even though maybe not at scale, not for every site, but at least to the level that they could potentially take over any site where it may become necessary. But again, those are different approaches. And in general, we from ABB try to support all of our customers in the respective approach that they have. So we do provide very basic input for the self-maintainers so that they are enabled to maintain the security of their system. But for those who want it, we also provide managed security services so that we actually become their trusted partner for protecting their OT environments.
Okay, that makes sense, at least to me. But it might be a bit more complex to some of the companies out there, because there you talk, you need some very interesting and good examples like Shell and versus other oil companies or oil and gas companies. So there the question would be then, if you say, okay, for one, it's more a commodity, for the other one, it's more a core process. How would that differ then in terms of their approach in the way that they should tackle cybersecurity? Is it because it's more a commodity that they don't really have to take those people on board? Is that the perspective that you're
typically that's what we see? Those customers that either don't have the size to afford such a specialized team, or the customers that have decided this is not our core competence, they typically turn to a supplier management. And there, the difference between the sizes of organizations may be visible. I don't have statistically relevant data on that, but if you think of a multinational corporation, they will have a more sophisticated approach to supplier management than a small mom and pop shop. Nonetheless, the point being, yes, those customers typically turn to a managed service provider, and they set out their policy, they set out requirements, potentially by the help of consultants, and then have suppliers that sign up for that contract and for that scope to be managing the security within the realms and within the constraints and with achieving the objectives of the respective policies. But the details of defining the procedures of day-to-day operations, that is then left to the service provider. While the ones who consider this the core competence, typically they don't do that at scale either. Some do, but that's limited. But they at least have teams that understand to the very nitty-gritty detail of how these things happen in day-to-day practices. And for any given site, they could quickly ramp up a team from their own internal resources that takes over should, for example, that service provider drop out or go bankrupt, or there's a challenge with it so that they want to switch. They maintain a lesser dependency on the service provider. Nonetheless, there's usually some very basic information that they need in order, for example, for doing a reference design, you need that architecture documentation, things like that.
Right. So would you recommend that there are some components that any company should still keep inside in terms of managing cybersecurity?
What you cannot delegate is accountability. What you cannot delegate is accountability. If you run such an operation and if you have potential hazardous operations for people or the natural environment that you work in, you cannot delegate the accountability for any damage that you inflict on anyone. So the least that you have to have is an understanding of the risk and a well-funded definition of your risk appetite. So what is the residual risk that you're willing to accept? And translate that into a policy that can then actually be specific to your service suppliers to actually do what needs to be done in order to maintain that level of risk. But again, you cannot delegate the accountability, and therefore you have to understand the risk and you have to be able to define why and defend why you are accepting the residual risk that you are accepting. And you have to translate that risk threshold into a set of policies and constraints that you can then ask your managed service providers to deliver in a day-to-day business.
that's definitely on the level of indeed on the accountability from a risk management perspective. But in terms also for cybersecurity, from a cybersecurity perspective, would you recommend that a company still includes some specific key resources and key skills that they should have on-prem, or that within the organization they should still be focusing on trying to have?
I don't, there's no black and white answer for that. That really, I've seen organizations that really go to the extreme of service provider involvement there, and that essentially are almost up to the point that they rent the control system operation. And it can be successful. It really depends very much on your strategy and on the level of commodity and commoditization of your operations. If you have a fairly standard process in large scale oil refining, for example, there's not that much differentiation in how you refine the oil to more market ready products. The chemicals and the process design in there is not really the source of differentiation for many of our customers there. And then yes, it may make sense to really say, look, I can do all of that with the help of service providers. And if you have more specific, if your value add really depends on the specific design for special chemicals, for example, then it becomes more relevant to actually own more of that know-how. But really, I wouldn't go to the point of saying this is the least that everybody should have, beyond really understanding what your accountability and what your risk is. After that, it really depends on where do you consider your value add, what is core differentiator to your organization.
Yeah. Okay, got it. Yeah, that was just a second. The unmute button that need to be found properly. No, I think that makes perfect sense. Of course, also in the viewpoint of many of our organizations that are currently seeking for such an idea on how to handle, and I think also from the perspective of giving the insight that not all of it has to be done from the inside. Sometimes it's of course finding the right balance between getting the right people inside that can also find their ways in managing even the external hired in expertise. So as a final one to you before I hand it over to Vincent, how would it work within ABB in this case? I guess that specifically for in this case also the products themselves. So there's of course the processes, the production process, but also finally the products themselves need to be cyber secure. So how do you relate to the cybersecurity of the products within ABB?
Yeah, so as I pointed out in one of the earlier slides, we generally structure our approach as a comprehensive one, starting from product design and implementation, release, and support, through project commissioning, engineering, and operations. And we have internal standards for all of that. We have internal standards for various types of products that ABB provides. We have internal security standards for how our project teams shall be commissioning and executing commissioning projects. And similarly, we have requirements, security standards for our service teams, be it for the generic services that have nothing to do with security, but shall be delivered in a secure fashion, as well as specific portfolio of services for managing security. So we have an internal governance scheme for cybersecurity, and we have done this for, I would say, roughly last 10 years. And in those 10 years, we have, of course, evolved the internal standards, and we've raised the bar. And we're more and more aligning ourselves also internally to the IEC 62443 standard, because that is the dominant standard that we see in the market for OT. And when we started our internal governance framework, that standard was not yet ready or mature enough to align with it. Many parts were still missing. In the meantime, the standard is out there, is, from my perspective, relatively mature and almost complete. We see more and more customers are referring to that standard as the backdrop of their programs. So it only makes sense that we drive our product organization and our project execution organizations towards that.
Do you have specific people also managing on the product side the cybersecurity of those products in that sense?
Yes,
Okay.
for all the product responsible units, for all the business groups and product groups, there is a cybersecurity responsible who's responsible to A, look after at least compliance with the minimum standards, and B, monitor the market. What does the market means? Because if you look at the breadth of the ABB portfolio, we cannot have a one-size-fits-all security design. There's a difference whether you're talking about a commercial building automation or home automation system, or whether you're talking about a control system for a nuclear power plant or an oil refinery or a large chemical facility. So while we have a common baseline, that's the minimum threshold that everything must meet. On top of that, there are market-specific and domain-specific requirements that come from the market, where those security responsible people will then also be the internal consultant to their product management to say, this is what you should be doing, this is the roadmap that we should in place for cybersecurity, where they are able to talk to customers, for example, to explain our approach, to give that kind of guidance in a strategic level.
Okay, so as a final one then for you, because you mentioned specifically the 62443, one of the challenges that we see today with 62443 is really towards digital transformation. It's mainly referring to traditional OT to traditional systems. I would call them in a previous discussion legacy, but yeah, some others might refer to it as just old systems. So it doesn't really reflect on the capabilities immediately that the current digital transformation and things like IoT, big data platforms, connectivity to the cloud really brings along. What's your view on that?
That's true. The 62443 series has been designed beginning in the early 2000s, where all this digital transformation was not at all a topic yet. But I think conceptually, it still focuses on the OT core parts, and that's probably going to remain the focus, but the connectivity and the integration to the enterprise and to a cloud environment will become more visible in the standard. I still am convinced that you shouldn't just hook up your field level to the internet and run it that way. Segregation and managed connectivity is still, I think, the reasonable route to go. And being able to tune the countermeasures and the security controls to the particular environment and the needs for that particular environment. So the zoning concept, I think, still plays a role that 62443 proposes. And there are activities in the committee to tune the standard to be more inclusive of the cloud-connected IIoT world. I don't think that it is making that obsolete. That's this trend will be adopted in the standard and will be reflected in the standard in relatively near future. But I think the approach that 62443 had from the very beginning, being a comprehensive security standard for the OT world, for industrial automation and control systems, that will remain. 62443 will not compete with the Cloud Security Alliance, for example, or similar organizations. But 62443 will open up the scope for integration more, that's for sure. And it will be able to support those more modern IIoT world kind of operational principles. But we will have to understand that there is a more complex world out there, and that there are different levels of standards and different sources of standards for the different parts of this system. I would still refer to the Cloud Security Alliance and organizations like the Industrial Internet Consortium for the cloud connectivity parts and for the cloud operations part. There, the specifics to the OT are really not that specific. But when it comes down to how do you actually connect your OT environment to that cloud, and what do you do? How do you protect the data that comes from your OT environment? What kind of data do you need to select? What can you, for example, do also in terms of improving your security posture by connecting to cloud services? Those things will be more and more also part of the 62443 standard.
Okay, perfect. Thank you so much, Ragnar. I'll come back to you later on with a couple of ideas also in relation to things like Industry 4.0 developments and security, because there's also a couple of things that some of our people are considering and concerned about. But I'll leave you now to get a coffee and to relax a bit, and hand it over to Vincent in this case,